video is on Unit 4, Chapter 9, Solving Polynomial Functions, Lesson number 2, Solving Polynomial Functions. In your notes here for zeros, it says that the points at which the function intersects the x-axis. So your real zeros, the real solutions, are going to be the solutions where your function hits the x-axis. The degree of the polynomial is the same as the number of roots or zeros of the function. Some of those roots may be real and some of them may be imaginary or complex. And there are three main methods that we're going to look at to solving these polynomial functions. One of them is going to be to solve by graphing. One of them is going to be to solve by factoring. And thirdly, a combination of graphing and synthetic division. So the types of solutions, let's talk for just a second about this. We've talked in the past that imaginary solutions come in pairs. So you cannot have just a 2i or a 4 plus 3i. You have to have both the positive and the negative. So if we have a degree 2, if our polynomial is a quadratic, what types of solutions can we have? Well, they can both be real. So you can have two real solutions, or they can both be complex or imaginary. But that's it. There's no way you can have one real and one complex because, again, complex comes in pairs. So what if I have a cubic polynomial? What are the possibilities here? Well, if it's cubic, all three of those can be real. But all three cannot be complex. So I might have one real and two complex. But that's it. Those are the only types of combinations we can have there if we have a cubic function. What if we have a quartic function? Again, all four of those solutions can be real. All four of them could be complex. Or we can have 2 and 2. So we might have 2 real and 2 imaginary. Or complex. I use those words interchangeably. And then for a 5th degree polynomial, quintic polynomial, we can again have all 5 of those solutions could be real. Or if I have 2 of them that are complex, that's going to leave 3 real. Or I can have 4 of them that are complex, leaving 1 real. So just something to think about there. Multiplicity is a new vocabulary word. Multiplicity happens when a factor occurs more than once. Multiple roots that are the same solution. This happened when we had perfect square trinomials. So for example, if I had x squared plus 4x plus 4 equals 0, that factors into x plus 2 squared. Or just some of you would have written x plus 2 times x plus 2, right? So when you solve that, you get the same solution, which means you just have one solution. So that means that there are multiple solutions. Negative 2 happens twice. It occurs twice. On the graph, when a function bounces off the x-axis, it creates an even multiplicity. On the graph, when the function bends as it crosses the x-axis, it creates an odd multiplicity. So think about what that looks like. If it comes down and bounces off of the x-axis, that means there are an even number of multiple answers that happen at whatever that x value is. And then for bending as it crosses, it kind of does that. So it bends as it crosses the x-axis. It doesn't just go through it. It bends as it goes through. So I want us to graph the function 3x to the 5th plus 18x to the 4th plus 27x cubed. And you're going to see what's an example of what's going on there. So I'm going to go to y equal, and I'm going to graph that 3x to the 5th power plus 18x to the 4th power plus 27x to the 3rd power. So right here, this is a bounce. It came up, it bounced off the x-axis and came back down. So this is going to give us a multiplicity of 2. And then as it's crossing at 0, it bends. That's an example of a bend. So for this problem, what it says here in the notes, the solutions are -3 with a multiplicity of 2 and 0 with a multiplicity of 3. Now looking at the degree, it has a degree of 5, so I should have 5 solutions. Because it bends at x equals -3, again, that means, no, it bounces at x equals -3. So you have 2 of the 5, and then it bends as it crosses at 0, giving us the other 3. So it says, notice how the graph bounces at -3 on the x-axis. Again, that creates the 2 solutions. Notice how the graph bends as it crosses the x-axis at 0, creating an odd multiplicity. Both cases create multiple solutions at each point. X plus 3 is a factor 2 times, and x is a factor 3 times. So there's a lot of vocabulary going on here that you need to be familiar with. Solving by graphing. The directions just say to graph each function and identify its zeros. So you're going to do just that. Let's do the number 1. We've got x cubed. I'm going to clear this out. I've got x cubed plus x squared minus 2x. So let's look at another. We should see 3 answers. This is a cubic function. We should see 3. It does hit the x-axis 3 times. -2, 0, and 1 looks like my solutions. -2, the y value is 0, letting me know that that truly is a solution. 0 and +1. So -2, 0, and 1. So I was looking for 3. I found all 3. I do want to look at number 2. I've got -x to the 4th power plus 4x to the 3rd power minus 2x squared minus 4x plus 3. Now, I'm looking for 4 solutions here. I'm looking for 4, and I only see this thing hitting the x-axis 3 times. However, right here where x is equal to 1, it bounces, which means that the +1 has multiple solutions, and it's an even number. So here's one of my solutions at -1. Here's another solution at 3. So 2 of the 4 are accounted for. The other 2 are at 1. And again, you can double check your table to make sure that those truly are solutions, looking for the 0 and the y. So -1, 1, and 3 are the 3 solutions. And then I would state that 1 has a multiplicity, I'm going to abbreviate that, of 2, meaning that 1 occurs twice. All right, moving right along. The sum and difference of cubes. So a sum and difference of cubes, this is solving by factoring, and it's also going to involve quadratic formula. When we factor cubic functions, there is a pattern. So you're going to want to learn these patterns. So for sum and difference of cubes, a cubed plus b cubed is going to factor into a plus b. So that comes from the cube root of both of those. And then we are going to square the first term to get the first term in the new trinomial. You're going to multiply the 2 of those together to get the middle term, and then square the b, or square the second term. And you do the same process for the sum of cubes as well as the difference of cubes, and the signs create like a little pattern. So if it's the sum, you got a plus here, it's going to be plus, minus, plus every single time. If there's a minus, if it's the difference, it's going to start out with minus, and then it's going to be plus, plus. So for example, let's look at number 3. We've got x cubed plus 27. Now all I'm doing here is factoring. To factor this, you want to take the cube root of x cubed is just going to be x. The cube root of 27 is 3. So because this is the sum, it's going to be x plus 3 in my binomial. For my trinomial, square the first term, multiply the two together, and then square the second term. And because it's plus, my signs are plus, minus, plus. Let's do a difference. X cubed minus 1. Take the cube root for your binomial, cube root of both. Make the sign match. In the trinomial, the signs are minus, plus, plus. So again, square this first term, multiply the two together, and then square the second term. So that's how we factor sum and difference of cubes. So in this next section, it says solve by factoring. So let's look at number 7. Looking at number 7, the first thing is to look for GCF. There is a GCF of 2x to the 4th power, and that's going to leave me x squared minus 5x minus 6. Keep in mind, y'all, that you do need to get a 0 on one side when you're solving by factoring. Factor the trinomial. We're going to tee it up to solve. I'm going to factor that the quadratic. So I need two numbers that multiply to give me negative 6, that add to give me a negative 5, which is going to be a negative 6 and a positive 1. So when I go to get my solutions, subtract the 1, add the 6, and then for this 2x to the 4th, this is a monomial, which automatically tells me that x is going to be equal to 0. There's 4 solutions, so 0 has a multiplicity of 4 because there is an x to the 4th. My 3 actual solutions are going to be negative 1, 0, and 6, and then we would state that 0 has a multiplicity of 4. I want to jump down to one where we can factor by cubing the sum and difference of cubes. Number 9, x cubed minus 8 is going to factor into a binomial and a trinomial. So cube root of x cubed is x, cube root of 8 is 2. Keep the sign. The next set is going to be plus plus, square, multiply, square. And then if you try to factor this quadratic, it is not going to factor. There's nothing that adds to 4 or multiplies to get 4 that adds to get 2. So what we end up doing here is we can take this first one and get a solution. But for the second one, you end up having to do the quadratic formula. X equals opposite b plus or minus the square root. B squared minus 4ac. So if I do the discriminant really quick, 4 minus 4 times 1 times 4 gives me a negative 12 underneath the radical. 2 times 1 is 2. So simplifying this, I get 2i radical 3 all over 2, which again is going to reduce one more step. So my solutions, all 3 solutions here, are going to be a 2 and a negative 1 plus or minus I radical 3. So there's my 3 solutions on that one. And I want to show you the last part of this, solving using synthetic division. The first thing is that we want to make sure that the equation is in standard form. Enter the function into y equal. We're going to locate some real solutions. And then what we're going to do is synthetically divide out those real solutions until we have a quadratic or a linear equation that's left, and then we can solve using quadratic formula or just solving the linear equation. So let's look at number 11. Actually, let's look at number 12. Let's look at number 12. Number 12, I'm looking for 4 answers. The degree on this polynomial is 4. So I'm going to first plug it, and it already says equals 0, so I'm going to plug it into y equal. So I got x to the 4th power minus 3x to the 3rd power plus 5x squared minus 27x minus 36. And I'm going to graph it. And it looks like I've got 2 real solutions, a -1 and a +4 are my real solutions. And sure enough, -1 and +4 are 2 of my 4 solutions. So what I'm going to do is I'm going to synthetically divide those out of this quartic polynomial using synthetic division. Let's bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add. Now, you should get a 0 on the end because it is a solution. There should be no remainder. Because it's a solution, it's also a factor. And that brings us down to a cubic function. And I'm going to go ahead and synthetically divide out the 4. Bring down the 1. 1 times 4 is 4, 0, 0, 9, 36. And again, I get a 0. Now, this is a quadratic. So I've decreased, I've taken out 2 solutions, which leaves me with a quadratic. So this is x squared plus 9 equals 0 that I can solve. I'm going to subtract the 9, square root both sides, and I get positive and a -3i. So my 4 solutions are -1, 4, and a positive and a -3i. All right, I'm going to do one more. I'm going to jump down to number 15. So I'm going to put the 5x to the 4th minus 20x cubed plus 20x squared into the y equal. And again, what we're doing here is we're looking for any real solutions that we can divide out using synthetic division. I'm going to graph. So if you'll notice here, this thing bounces off of the x-axis. So I'm looking for 4 solutions, and I see all 4 right here. So it looks to me like a 0 and 2 are my solutions. So 0 and 2 are going to be the only 2 solutions that you are going to find for problem number 15. 0 has a multiplicity of 2 because it bounces. And 2 also has a multiplicity of 2 because it bounces off of the x-axis. Now you can prove this by going through the synthetic division. I can take out the 0, not the 0. I want to take out the 2. Again, you can prove this by going through the synthetic division. You do need 4 through 2. You need to add a couple of zeros here. So 10, -10, -20, 0. And you're just going to continue to get zeros here. You could pull out another 2 if you want to test your theory. So you have 5x squared is equal to 0. Divide by 5, you get x squared equals 0, square root, and you still get 0. So we've got some work to do to kind of clear up any questions in class, but these are your notes for chapter 9, lesson number 2.